Okay, so again, here's a working model before the universe. This would be the singularity, this stage here. All of this is cold, this is hot, this is warm. So let's say a universe has already burnt out. All of that energy is now liberated back into just pure energy. So we have the electrons and neutrinos. Now at this point, it's buoyant, flat. I've explained this before in a video. You could say this is the big rip. Now let's say all these pieces of paper are electrons, okay? And they move so far apart, everything has moved so far apart that now it's in equilibrium at absolute zero. This would be the big freeze or the heat death. It's in equilibrium. It's sparse, interspersed. So it's an invisible lepton cloud. Negative 460 degrees, roughly. Absolute zero. This is also the Planck epoch. This is also the lepton epoch. It's also false vacuum decay. Now, prior to all these particles in here that were ushered in by the void of space, it was just an empty vacuum. But even the vacuum wants to decay into something. So once it starts to decay, this is the big crunch. This is when gravity starts to crush everything. Because even though all these particles are so sparse and spaced apart, as a whole, when they come up to an equilibrium, absolute zero, they re-entangle with each other. And it starts to get denser and denser and denser, and it's so heavy at this point and hot that it's warped space tremendously. Now, this is about thermodynamics and a little bit of quantum mechanics in there, but it's majority. Anyone can understand quantum physics, quantum mechanics, as long as they know thermodynamics. That's something that scientists are throwing under the bus, and they're pretty much erasing. They don't even consider it when it comes to science like this, when the universe itself is nothing but degrees, which are angles and temperatures, cold, warm, and hot. So this is like a water cycle. So everything's at these point where it's electrons, just leptons themselves with half spin. The energy equals mass. Now this would be winter, cold, nuclear winter. And then it's going to start springing up. Now the thing is about spring and fall is they share a nexus point, and I'll get to that. And that's important understanding this. So the mass equals weight, and the energy equals weight, meaning the weight equals gravity. This is the conservation of energy right here, something that scientists don't know anything about apparently, because they like to confound this situation and make it where people have a hard time understanding it by throwing out temperature. So it's gaining mass and it's gaining spin. Now, since this is the negative aspect, because this is all leptonic, this is a -1 value, not to mention the spatial value is -1 because it's inconsistent. I explained the spatial value on the last video. So this is where your W negative boson and your Z boson are. This is where they play in, because these are going to be forces that are residuals of the singularity itself, which does have a neutral charge because it's neutronic, but it gains a +1 charge. So it goes from a negative to a neutral to a +1. And this is where the W negative, the Z boson, and W positive boson all play in, right here at the singularity, which is basically the Higgs boson. And it has a spin of 1. The only reason we can't measure it is because it's relative to fifth dimensional hyperspace. I've mentioned that before. So the big bounce occurs, boom. Anti-gravity starts shooting out, basically the spreading of the universe, which is dark energy, time, entropy, what have you. And it's cooling now from its hottest point. This is the neutrino decoupling. This is also a zinc spark when it comes to biology. And it's an impact flash when it comes to cosmology. When, let's say, a comet hits the planet. Collision, that's an impact flash. So you have neutrino decoupling, the zinc spark, and impact flash all mirroring each other on each scale. The macro, which is quantum, which means big and small, that's 1. The zinc spark, which is biological, and the impact flash. Now when it goes from this hot liquid plasma and it starts to spread out, you have your population 3, your population 2, and your population 1 stars. So that clear buoyancy in thermal equilibrium starts to condense, it turns into a cloud, a vapor. Essentially, the vapor creates a cloud. It goes from clear to a cloud, like a nebula. It's really buoyant. The cloud is diffuse, meaning it's in equilibrium with its surrounding space and area. It's interspersed, and it has solids, liquids, and gases inside a cloud. Now, it's majority gas, but there are liquid drops, and there are sand and dust also, meaning you have your solids, liquids, and gases in here, which mirrors the singularity, which creates solids, liquids, and gases. Now, as it's spreading out, it's getting more diffuse, or it's diffusing. It's diffusion and diffusion, meaning it's getting more diffuse as it spreads apart, and it's defusing, meaning it's liberating all of its energy and gaining entropy. Now, it has a lot of energy, and there's still fusion going on, but as a whole, it's losing energy, just like we are. We still have a lot of biological activity going on in our bodies, but we're aging, meaning we're decaying slowly. Entropy's catching up with us. The universe is no different. It has a metabolic function just like we do. It metabolizes energy, stars. So when the universe rains and hails, that's stars, which are liquid plasma, that's raindrops. Then you have your hail, which is the planets, the moons, the solid material. Then you have snow, which is similar to both, intertwined. It's very sparse and spatial. That means whenever it hits the ground, it's fluffy. It can be packed further. So this would be analogous to both mixed. It's not dense at all. So the universe rains and hails. It falls because it's cooling, fall, and I'll get to these. And then it warms and it rises, where it's going to cool again and condense and then refall in a circular pattern. And it's decaying as it does this. It loses thermal energy. Then it gets hot and starts to turn into invisible vapor again, putting it back into an equilibrium, similar to this flat buoyancy here in space. So liquid or plasma is a combination of gas and solid. It's 50% gas and it's 50% solid, making it a liquid. Of course, solids and liquids are made of gases. All the elements on the periodic table are essentially gas. Energy that froze up and got hemmed up, similar to ice. But instead of water that's frozen, it's energy that's frozen. So in the future, when it goes back to its nuclear winter, everything's starting to burn out, it goes back to a vaporous state or invisible. Now, right here, you have summer at the top where it's its hottest. That would be analogous to the W positive boson. You have winter down here at the bottom, which is the cold, which is analogous to the W negative boson, W minus. But spring and fall share a nexus point, which is 0. This would be the neutral zone. A nexus point essentially, basically, in this aspect, is where two opposing factors share a commonality within a certain range of time or position, however you want to look at it, whether it's physics, temperatures. Technically, a nexus point only applies to biology, but I'm applying it to physics. Because spring shares 50, 60, and 70 degree weather, whereas fall shares 50, 60, 70 degree weather. But one has a temperature variant that is rising, one has a temperature variant that's falling. But they share a cusp here that is a neutral zone, which is what I call a nexus point. And just like whenever you have cool condensing gas, it can turn into a solid. Now, the thing is about ice is it expands 9%. It's inflating when it cools. It inflates as it cools. It's turning to matter. In this aspect, you can imagine here that your positive and neutral are both the hydrogens, and your negative is your oxygen, and that would be analogous to an atom. Now, we know it's a molecule, but it's the same as the atoms forming, but once the atoms form, the molecule of water acts the same way. So through here, while it's springing up and getting warmer, it's going to be about 2.7 Kelvin warming. It'll reach its hottest at the summer, which is the singularity quark glowing plasma. It transitions, drops state to 2.7 Kelvin, cooling. Now 1K, or 1 Kelvin, is basically 1.8 degrees. 2.7 Kelvin is basically negative 270 Celsius, or negative 454, 454 Fahrenheit. The 1.8 is 0.6 times 3, and the 2.7 is 0.9 times 3. And 54 times 4, hence the 4 times 54, would be 216, which is 6 times 6 times 6. So the degrees are also angles, and or temperature are angles or degrees, and spin is an angle, angular momentum.